Okay, I wanted to finish up the topics from section 1.1 that we didn't get a chance to finish. I'm doing this for 3 sections and we all stopped at slightly different places, but I'm going to just do the ones that I know everybody missed. So we were talking about domain and range and how to identify domain and range from different types of presentations and sometimes doing interval notation when it was a smooth line or a curve. And for most of us, that's about as far as we got. So I would like to study or talk about what is a function and how do you recognize it in all those different forms. And then also there's something called function notation. And I think one of the classes I got into that a little bit. So let me go ahead and share. I think I'm going to start with the quick notes here. So when we talk about what is a function, it is some kind of a relation, like the things we've been looking at that have domain and ranges, but it's a special type of relation where each domain value is unique. So a couple of the classes, we built a table based on wages earned, if you knew how many hours you had worked at the minimum wage. So we had our X values were hours and our Y values were dollar amounts. That would have been an example of a function because if you knew a specific number of hours, there was only one point that was going to go with that. There was only one amount of wages. So in other words, if every domain value is unique, that means you're not going to have points that have two of the same X value, no repeated inputs. If you have two ordered pairs that have the same X value but different Y values, then the Y value doesn't depend on X because I could choose that X value and still not be able to figure out what Y is because there's more than one possibility. Okay, so another way of thinking of it, and sometimes when it's a verbal description, think to yourself, if I were to choose a specific input value, would there only be one choice, one pair that has that input value for X? If there's more than one pair that has that same X value, you do not have a function. Okay, so I want to just look at a couple of examples like you see in the homework about different presentations, and it's just kind of a yes or no question. Is this a function or not? So the easiest ones is if they just give you a list of ordered pairs or they show you a table or chart like this where you can clearly see the XY pairings. I'm going to assume in all of these that X is the input and Y is the output. Okay, I'll say that right now. So when you're given a table or list of points, to answer the question about whether or not it's a function, all you really need to do is just look through all the X values and make sure they are all different. So every one of these X values is different. I do not have any repeated X values. So that's all I need to look at to determine that, yes, this particular relation is also a function. Now you may have noticed that I have a Y value that repeats a bunch. I have -8 that repeats all the time. The Y values repeating is not anything to do with the definition of a function. The function is a one-way deal. If you choose a specific X value, do you only have one choice for the Y value that goes with it? So for every one of these, since all the X values are different, everybody said, hey, what's the Y value that's paired with X equals 0? Say, oh, well, that Y value is -8 because there's only one pairing here where X is 0. So since all the X values are different, we would say, yes, it is a function for that one. And if you had a list of ordered pairs, again, you would just be checking the X values for the list of ordered pairs to make sure they were all different. If you see any repeated X values, then it's not a function. All right, so let's look at the graph here where we have pictures and we have to kind of identify what the X value would be for each of these points. So this X value on this first one is -2. This one will be -1. This point down here has an X value of 0. And then this point up here has an X value of 1. And this last point that I'm pointing to down here also has an X value of 1. So I could write down the coordinates for this point up here, and it would be 1, 2. And the coordinates for this bottom point would be 1, -1. So there's an example of 2 points that have a repeated X value. So if I were to ask you, hey, what is the ordered pair that starts with X equals 1? You would have too many choices. Well, one of them, it ends at 2. The other one, the Y value was -1. So I do not have a unique answer for that because I have the x value of 1 being repeated. So this is not a function. When it's a picture on an XY grid like this, it is true that if you have any part of the graph where you have 2 points aligned directly above and below each other, that means that they both share the same x value. If I were to kind of put a dotted line right through here that hits both of those points and also hits the x-axis at 1, every vertical line has an equation that's just basically x equals whatever that number is right here where it hits the x-axis. So if you were to graph a line that says x equals a number, that's going to be a vertical line that hits the x-axis on that number. So if you have a vertical line that's touching 2 points at the same time, that's an example of something that is not a function. Okay. Now sometimes it's not points, but it's a smooth curve. It's the same kind of idea here. Kind of ignore this. These are the questions from the homework that asked this type of question, number 3, and then 9 and 10 and 13 and 14. But let me go and show you a graph of something like this to kind of emphasize that vertical line kind of idea. Hang on. Let's put that back. I'm going to stop sharing that and then go share the. I think it's here. No, pardon me. Let me go grab the right image. Got too many things open here. It would be. Oh, where did it go? Yeah, okay. Sorry about that. Took a second. Okay, so here's an example of this is that function that I just graphed down the Desmos so we can see this red graph here is an example of a function that came from an equation. That's why it's a smooth curve. And in fact, if you wanted to know what the equation was, that's what I have over here, this y equals x squared minus 4x. But even if I didn't have that equation shown and I was only shown this picture, I can still determine whether or not this is a function by imagining a vertical line and seeing if I were to kind of roll the vertical line across the graph, would it ever touch this graph in 2 places at the same time? So that's what, if you look over here, this blue line, every time I stop it somewhere, like right now, it's showing us the line that has the equation x equals -3. So that blue line shows us all of the points that have an x value of -3. They all line up on that same vertical line. So I haven't really hit the graph yet, at least where I can see it. But if I keep sliding it, one nice thing about Desmos is when you have 2 graphs that are touching or intersecting, if you click on it, it'll kind of light up a little point there and you can sort of estimate what it is. But clearly we're hitting the graph now, but as I move that thing across over here, as I move it, the blue line through the red graph, it only ever touches the graph 1 point at a time. You can see that little gray point that's sort of sliding down the hill and it hits the bottom. Now it's going back up the hill on the other side, but we never hit this graph in more than 1 point at the same time. So that means it is another example of a function. So if we were to go back on that example, we would say, yes, that is a function. As opposed to, while I'm on this screen, let me line up a different picture. All right, here's a picture that has kind of a similar picture, but it's kind of flipped over on its side. This is kind of like that picture we were looking at on our papers in class that had the oval kind of a shape. If I were to take this vertical line and start to move it across the screen, when it right at the tip here, right at where that turning point is, it hits it just that one single point. But after that, any place where I'm intersecting it, I'm hitting it on the top piece and the bottom piece at the same time. So this would something that is not a function because I just picked one of these x values like, tell me what's going on when x equals 3. So I kind of find, there's the blue line that shows all the points where x is 3. Well, one of the points up here, it hits it at 3, 4, hits the green line, and then down here it hits the green line again at 3, -2. So there's an example of an x value that repeats on that green line with two different y values. There's one up here and there's one down here. So that's not a function. So anytime you have a function that kind of doubles back on top of itself, where you have two different pieces that are sitting on the same vertical line, that violates the definition of a function. Again, because if I said, hey, what's the output when x is 3? You find the x value of 3, but then there's two plates. Let me just move the line off of it and just talk about that. If I were to go down here on the x-axis and find the x value of 3 and say, what's the point on the graph that's associated with x equals 3? You have too many choices. You have one up there, but you have another one down below. So it would not be a function. Okay, so that's just a visual example of how to look at a graph of something and determine whether or not it's a function. That particular, let me give you another kind of definition here. When you're just looking at the picture and you're just taking, in your mind anyway, a vertical line and you're just kind of sliding it across to see if it ever hits it more than once, that's just a visual test, and we call that the vertical line test. So if you're looking up something in the examples or something and it refers to the vertical line test, that's just the idea that for it to be a function, there can be no vertical line that touches the graph in two places. So a function graph will not touch a vertical line in more than one place, more than one point. And that's all you have to do is just kind of look at it and see, is there any place where a vertical line hits it twice? If it hits it twice, not a function. If it only hits it once, it is a function. Okay, so that's the idea with the vertical line test. And that's what I was doing when I was rolling that blue line across the picture, just to see if it ever touched it more than once. Okay, so yeah, sometimes the more difficult question about whether or not it's a function is when it's talking about a verbal description of the inputs and outputs, and you're trying to decide if you could have repeated inputs or not. So if you look at something like this, I've already mentioned this one earlier, but if we decide the inputs are supposed to be the hours that are worked and the outputs are supposed to be the wages that were earned, and again, we're assuming we're hourly wage of the same amount, $7.25 was minimum wage, then ask yourself, if is y a function of x, then if that's true, then that means if I choose a value for x, there's only one type of y that can come out. So for example, if I worked 10 hours, would I be able to figure out how many wages or how much was earned in wages? And the answer is yes. You would just take that and multiply it by the hourly wage. So if I knew a particular number of hours, I would be able to determine the unique value for the wages that were earned. Okay, so since this does fit that definition that we're talking about, if I know an x value, I know specifically only one y value that can answer the question, then it also is a function. And specifically, we would say y is a function of x. So sometimes it's a one-directional thing. So in this case, you have to know x first, and then you can figure out the y's answer once you pick x. So y depends on x, so we say y is a function of x. Okay, we'll come back to that in a minute. And then here was one more where if we decided that our inputs were a person's age, let's say we're talking about our students, all that HIPAA information I really am not allowed to have on you guys anyway, but let's pretend. So let's say if the inputs are a specific age, okay, and the outputs would be the student with that age, okay, in our class. So if I picked the age is 19 years old, if I had a specific age, would I know what specific student is that age? So if there's more than one answer to that, so in other words, do we have more than one 19-year-old? Is it possible to have more than one 19-year-old in the same class? It is possible. So just because I know someone's age doesn't mean I know who it is. There might be several people that have the same age. So age is not a function. I'm sorry, knowing which student it is not a function of knowing their age. Knowing someone's age isn't enough to make them uniquely identified. Okay, so this one would be no, because you could have more than one student with the same age. So that'll come in the homework when they have a couple of things that are just described like this, and they're saying, is this thing a function of that thing? So student is not a function of age, because you can't choose an age and determine the unique student that that's talking about. Okay, so that's just identifying whether or not things are functions. And then the main last thing, I guess, actually, I'm going to go ahead and stop this one, and then I'm going to go make another one just so they're not so long. The videos aren't so long. So that's the one on just what is a function. And then I'm going to do another one on what function notation is. So let me stop this one, and then I'll start another one.